Kia ora, Year 12 and 13. Here are the latest 5 trig identity questions from D34.2. So you'll notice they're starting to get a little bit harder, but they're still just using the basic Pythagoras trig identities in slightly more interesting ways. So this one here, first one, number 7, we've got sine squared x, cot squared x, plus sine squared x, and we notice we've got a common factor in there. A common factor in there, just have to change stylus, sorry, that one is a bit too noisy. Sine squared x, right, and then I've got cot squared x plus 1, right, should be starting to feel familiar. That's sine squared x. So cot squared x plus 1 is cosec squared x, and then we've got, what have I got now? Oh, well then I'm done. I've got sine squared x, cosec is 1 over sine, so I've got over sine squared x, and that equals 1, so I am done. Next one. Oh, I didn't mean to do that. Okay, on to the next slide. Right, I've written this question down, sorry guys. What you're meant to be proving, I'm just going to, sorry, very low tech here, I'm just going to erase that. So we're trying to prove that sine squared x, sec squared x is equal to sec squared x minus 1. Right, so we're going to start off as usual by writing down the left hand side. Sine squared x, sec squared x is equal to sine squared x over cos squared x. Okay, so what do we need to do now? Well, we recognise that that is tan squared x, and we know that tan squared x is just sec squared x minus 1. So that one was actually very easy, but you've got to make sure you remember your definitions of the reciprocal trig functions. Okay, so sec is 1 over cosine. On to the next one. Right, we're trying to prove something about the difference between cot squared and cos squared. So write down the first line. There we go. Now, nothing really obvious springs to mind here, so try just inserting the definition there of cot. So that is cos squared of x over sine squared of x minus cos squared of x. Right, now let's simplify. On the bottom line of the fraction, sorry, the denominator, we have sine squared of x, cos squared of x minus sine squared x cos squared x. Right, now let's see what we've got here. Well, we've got a common factor. Take out the cos squared on the top line. And write it like that. So that's fine. We could extend that fraction there, it doesn't matter. Right, you can tell they're harder because I'm starting to nearly run out of space on one slide. So cot squared of x, and we know that 1 minus sine squared of x is just cos squared of x, which is what we had to show to start with. Okay, I am going to do how many more? I'm doing number 10 and number 11, and then I'll do the rest in a separate video because they get quite a bit harder. So on to number 10. Right, number 10, we are trying to prove that this is true. So we've got sine of x over cosec of x plus cos of x over sec of x. Right, what do I do when I've got a fraction? When I've got two fractions added together, I look for a common denominator. So we'll do that here, and we get sine of x, sec of x, plus cos of x, cosec of x. So far so good. Right, now we're going to have a look at that. Again, nothing much springs to mind. So I'm just going to get rid of my reciprocal trig functions is a useful strategy. So we'll try that. So sine of x sec of x on the top line is sine of x over cos of x. Right? Cos of x, cosec of x is cos over sine of x. Right, now what have I got on the bottom? Well, I've got 1 over sine of x cos of x. Right, so this looks a bit worse than usual, but it's not. I'm just got dividing fractions, so I'll move over here. So I've got sine of x over cosine of x plus cosine of x over sine of x. And then if I'm dividing by this thing here, I'm multiplying by its reciprocal. So I'm multiplying by sine of x, cosine of x. Now I need to pop a new slide in here, so just wait for that to come up. Right, so I'm going to write that line out again. If you could also let me know in class if these transitions are working where I add a slide in as I'm going, that would be good, because last year I had a little bit of trouble with that when I was just starting to do these. Okay, so we're down to here, and let's have a look at what we've got. Okay, so I've still got the sum of two fractions, and I need to do something with that. So we'll do a common denominator in here, cos of x, sine of x, and I'm going to get sine squared of x plus cos squared of x in here. Now hopefully now you see that the whole thing's going to collapse very nicely. Right, so that simplifies with that, so I'm left with sine squared of x plus cos squared of x, and that's just equal to 1, which is what I was after the whole time. Right, one last one to do. Right, trying to show that this thing here is equal to 1. Right, and this time, just to save time, I'm not going to write that left hand side out, but that's how you should start. So the left hand side, I really don't like doing this, but there you go. There's nothing obvious to do here, except I've got these reciprocal trig functions. I've only got one of them. So we'll deal with that, and we might rewrite tan as sine over cos. So cos of x divided by 1 over cos of x minus sine x over cos of x, sine of x. So that's what that all equals. Okay, so now I'm missing a couple of brackets in there. Oh no, that's right. Okay, so we've still got a big mess here. So we need to look at this, and this is cos of x on the top line, divided by, we'll put all of this in 1. Well, I've got cos of x here, and I've got 1 minus sine squared of x here. So it's starting to look much better. New slide for the very last bit, and then I'll copy that out again. Alright, so we had cos of x divided by 1 minus sine squared of x over cos of x, and that's cos of x times cos of x over 1 minus sine squared of x, which is cos squared of x over cos squared of x, which is 1, and that will be plenty for this evening to keep you all happy. Hope you've had fun doing those, and I'll be back for the harder ones probably sometime tomorrow. Thank you for watching. Oh.